Hello friends, why machine learning multi-class model fail and how engineers can fix them. Today we will try to understand this problem and the root cause of this problem, how you can figure it out and fix the problem. If you are .NET developer and you already built binary classification model in ML.NET, and then you are thinking multi-class classification feels straightforward, simple, as you already did in the binary classification. It's look similar, but this is not similar. Why? Let's break out this thing. Model looks similar because the pipeline is same code structure you used, same labels you use, but just more labels, because in binary classification you use one label, now you use more label. But in the practice where it's break, it's break on the production. Why? Because accuracy drops suddenly, prediction feels random. Sometimes model predict the same class for each input. This means that model is not correctly trained. So here we try to understand why this happened and what are the precautions which you can take while you are training model, choosing right trainer and choosing the right algorithm for your model. So let's continue in this. Binary classification and multi-class classification mind shift. This is very important. This will change the way of thinking when you know binary classification and you are moving with a multi-class classification. So if you look at here in the binary classification, what you have very simple predictions, whether yes or no. Binary classification answer in a two class with this is if your outcome in a two class is either yes or no, then you choose the binary classification. But in multi-class classification there are more than two classes. So this is one mindset shift you need to understand, because multi-class classification choose one option out of many. Why? Because you can look at here in the multi-class, in this image here we have example simple decision yes and no decision. If there is a third class comes, then it is considered by multi-class classification, not binary classification. And most failures happen, teams reuse binary thinking in a multi-class classification. Let's try to understand what are the problems or what are the mistakes those were intentionally, not intentionally done by team, and we need to figure it out those mistakes. We will definitely very predict, we will take it and we will very curious and to know those corrections, and obviously you will take the precautions while you are building and training your model. So let's try to understand one by one the problems which you can face if you are training your model with the multi-class classification algorithm and you have a mindset with the binary classification. Incorrect label handling. In the binary classification, you will provide same simple category. As you can see here, label column name is equal to category. You provide the one label and then your model will train and then give the prediction. That's accurately fine. Why? Because you have only two classes, either one or two class, one or another. But in the multi-label classification, we have to choose. In the multi-class classification requires key-based labeling. We need to provide the key-based labeling while we training our model, and while we predicting, then we map key to value. So let's understand in the simple way. First you need to map value to key before training, and after training you need to map key to value, so that that's utilized for the prediction. This is the one bigger thing happen in the multi-class classification if you don't change your mindset. Next, class imbalance. You have a data set and that data set contains more than two classes and you have a binary model mindset, then this class imbalance will happen definitely, because binary model can sometimes survive imbalance. Multi-class model usually cannot survive the imbalance. The model learns that ignoring minority of classes still gives good accuracy in the multi-class, because each class have certain value. So here you can see the C class will have a weightage of 10%, while A is 70 and B is 20, but this still have, yeah, still have value. It's good for the accuracy. So always check distinguishment and evaluate per class matrix. Never believe or never trust on overall. Always go dig it down one by one class. That's very important while working with a multi-class classification. Next is choosing wrong trainer. This is important. Definitely every topic is important, but this is also important. Choosing wrong trainer. If you are using machine learning .NET, then you have several trainers in the classification. As you already known through regression, you have several trainers, but the question is, you should have understanding at what time, what kind of data you have, and what kind of problem you have, which is the right trainer for you. So choosing a right trainer is a math. This you should understand. If you choose the wrong trainer, often definitely this leads to unstable or biased prediction. So your prediction would not be right. So the trainer's choice, I craft the trainer choice here at what kind of data you have, then what trainer you should choose. So SDCA you can choose if you small and clean data. LightGBM, large complex data. Text heavy, maximum entropy, then we can choose. So without considering data side, you may run into problem while you're choosing your correct trainer. The next is weak feature engineering. Feature engineering, guys, always plays crucial role in the machine learning. While you are preparing your pipeline, always think, always analyze each and everything, each and every point in the feature engineering, because that may create several difficulties for you, for your model in the production. Too few features. If you have too few features, your data is very less. Categorical data not encoded, because you have a categorical data in your model but you haven't encoded it, you may run into problem. Raw text without normalization. Categorical you can divide, you can convert into categorical one hot encoding, and if you have raw text, must normalize it. And unscaled numeric value. If your numeric values range are started with a minus, started with a zero and go with the millions and billions, then must normalize, because you have to keep your data in a scale. So it scale you. If your model predict the same class for every input, this is the bonus point, guys, for you. This means there is a problem in the feature, not problem in the algorithm. Next, misleading metrics. Till now you understood and you know binary classification, where you know the confusion matrix, where you can see the confusion matrix here. There is 2 by 2 matrix. You see this confusion matrix is plays very important role. So this could be mislead if you are completely depend on the accuracy. What you need, you should need to evaluate macro accuracy, log loss, per class confusion matrix. If one class dominant prediction, if one class is a plays important role or playing a dominant role in your prediction, your model is not learning correctly. This is one of the mistakes generally done by developers. Please keep your focus here. Next one is debug checklist. Before blindly ML.NET or any algorithm, you should debug your checklist. How you can debug your checklist? Are labels mapped to keys? Is class distribution balanced? Is the trainer appropriate for data size? Are features strong enough? Are per class matrix abilities? This we discussed just in previous slide. In the multi-class classification, you must evaluate matrix for each class. This is very important, guys. If you are interested and you want to build your scalable module, scalable matrix pipelines using the classification in the machine learning.net, then continue to watching my videos. In the next coming videos, I will record further session. Well, I will talk how we can use right trainer for the industry problem, what problem you have, and which trainer you can use to solve your problem. So do your practice, continue and watching videos. Thank you very much, guys.